All right, we're looking at worksheet A18 today, and we're doing the second part of talking about what their square root. So we talked about the last couple days breaking down a roots with the biggest perfect square. So you can check to see if you simplified a radical by correctly using the calculator. So here's the idea. We have the square root of 32. If we ask you for an exact answer, you're going to find the biggest perfect square, which would be 16. Now remember, when we're finding the biggest perfect square, there's other ways to do it. You could find the prime factorization of 32 and then build your bases. But the thing that we were doing, what we were doing was going through our list of perfect squares. Now, I will tell you that 4 goes into 32, but it's not the biggest perfect square because 8 breaks down the other factor. If you kept going, you would find 16 and 2. So the simplified version of the square root of 32 is 4 square root of 2. That's the simplified version, and that's what we've been focusing on. Now, what we need to talk about is if I put the square root of 32 in my calculator. All right, put that in your calculator. Square root, second, and then your x squared key, which is your square root key. Now, there's a second root key, but that's the x root, and we don't want to use that. We want to use the square root key. So square root of 32 is what decimal? 5.6, and it keeps going. The idea is that this is an irrational number. It does not terminate, okay? So the square root of 32 is 5.65685, and I'm just going to go dot, 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 showing that this number goes on forever. Now, let's take the simplified answer, 4 times the square root. So you can type in 4 times, you can type in 4 with the square root sign. Again, make sure you're not using this key. This key has that x root, and that means the x is defined as a cube root or fourth root. So be careful with that. So we're taking 4 times the square root of 2. I like to close a parentheses for good measure. And you see that I get the same decimal. So it's understood that when it's butted up against it, it's 4 times it. So we get that same decimal of 5.65685 dot, dot, dot. So what do you notice about the numbers 1 and 2? They are the same decimal. Now, if you look down here, the problem is you might think you got it right, but you didn't simplify it enough. So this is the correct simplification. But remember I said 32, 4 is also a perfect square that goes into it. So if we type in 2 square root of 8, 2 square root 8, do you see that I get that same decimal? So it can be a little confusing because you think, well, I got the same answer, I must be right. But the problem is this is not simplified enough because 8 would break down and you'd have 2 square root 4 square root 2, which is 2 times 2 square root 2. It doesn't give us that 4 square root of 2. So the idea is you've simplified it, but not completely, okay? So that's what I want to make sure I brought up. Now, if we jump down, this is nothing new. We are going to look. Now, if this is not multiple choice, I have to just jump in and break it down. But if it's multiple choice, I could try to see if the decimals were the same, but I have to watch that I don't get more than one the same decimal. All right, so 720, what is a perfect square that goes into 720? Well, 35. No, 35 is not a perfect square. 33. I was going to go with 36 as a perfect square. So let's try 36. Take 720 divided by 36. The reason I'm picking 36 because 36 times 2 is 72.
Oh, you're just so smart.
Well, no, because I'm not there yet. 36 is a perfect square. How do I know it's not the biggest perfect square without having to go through this whole list? Because I'd have to go to 360. Look at the 20. Do you see 20? So 36 is a perfect square. We like it. But 20 has a perfect square factor. What is that?
5 and 4.
4 is the perfect square factor. So here's the trick. You ready? Take the perfect square that you found and the other perfect square you found. If you remember your factor trees, 36 times 20 is 720. So 36 times 4 times 5 is 720. What's 36 times 4?
5 is 720.
36 times 4 is 144, right?
Yep.
So why not use 144 and 5? Look, 36 times 4 times 5. So 36 times 4. If you take a perfect square times a perfect square, you get a bigger perfect square. And then we have times 5. Now double check this. Is 144 times 5? Yep, 720. How do I know I got the biggest perfect square? 5 doesn't have a perfect square factor. What's the square root of 144?
12.
It is 12. So 12 square root 5. So we could keep trying the list, or we can find a perfect square and then move from there. I'm hoping number 6 sort of stands out to you. It's 640. What is a perfect square that goes into 640? 64, because it's 64 times what? 10. Now, did we find the biggest perfect square? Well, how do you know that? So I agree with you that 10 breaks down with 5 and 2, but are those perfect squares? No. 4 is a perfect square that gives you 2 as a square root. Do you see it? So that's actually the biggest perfect. So like 20 divided by 4. So we could break it down. But 10, yes, it has factors, but none of them are perfect squares. So then you found the biggest perfect square. So this should be 8 square root of 10. Okay, so yes, 10 breaks down, but not with one of these numbers. All right, flip it over, please. I think originally this was multiple choice and kids just burned through it. So we are going to work on it. Now, 1053. That's a big number, right? I can tell you that even numbers like 4 and 16, they're not going to go into it. Has to be an even number to divide. Did you ever think about that? If it's an even number, it can divide by an even number, but an odd number, that's not going to work out for us. So give me some ideas. Does 25 go into it? No, it has to be 50. Does 36 go into it? Are you trying these? Take your calculator, take 1053, divide by 36. No? Okay, 49. 1053 divided by 49. Is it an even number? All right, keep going. 64. Oh, 81 works? Okay, now hold on. Is it the biggest one? What was it? 81 times what? Okay. Well, 13 is a prime number, isn't it? So it doesn't have any factors. So 81 is your biggest perfect square. What will we have here? 9 square root of 13. Okay, so some of these numbers are a little bit bigger. 432. Go ahead, look at that one. Yeah. Okay, so the first breakdown we had was 36, and that works, but it was 36 times 12. So, yep, 36 is a perfect square, but I know it's not the biggest because 12 has factors. I'm not worried about the 2 and 6. What am I worried about? The 4 that goes into 12, right? So there's two ways you can play this. You could keep going through your list to make sure and exhaust all possibilities, and you'd have to go up to 200 something to double check this. The other option is 36 is a perfect square you found, right? And what's a perfect square factor of 12? It's 4. Take 36 times 4. 36 times 4, and you get 144. So if you can put the perfect squares together and you multiply them, then you will find the biggest perfect square. Is that making sense, what I'm doing? If you remember your factor trees from when you were younger. If 36 times 12 works, then 36 times 4 times 3 works. We're replacing the 12 with 4 times 3. So put these parts together and leave the 3 on its own. That's the biggest perfect square. 3 won't break down. And so I get 12 square root of 3. Final answer. Okay, now look at number 9. I went ahead and added some multiple choice options here because the numbers were big. So I think the best way to do this would be take your calculator and get the decimal. The square root of 1,859. Oh, I just did the wrong one. Square root of 1,859. Now, it's what, 43.116? So approximately 43.116, and it keeps going. Now, go through your multiple choice, all of them, and see, because there could be more than one that's equivalent to that. So go through that and see if any of those work. Let's look. This is the approximation. Rather than me breaking down this big number and trying to find the biggest perfect square, I'm going to use my multiple choice to help me. So I created this multiple choice. This would be 13 times the square root of 143. Now, I don't get the same decimal. Do we agree? So it cannot be this. Then I'm going to go down to 13 square root of 11. And I get that same one. Now, before I'm done, I could have two of the same answer. Now, I don't think that's going to happen here. 143 times the square root of 13 is going to be much bigger. I mean, 13 square root of 11, this is going to be much bigger. So it's not this one. And then this is 11 square root of 169, and that's 143. Okay, do you see what happened to this one? Whoever did this one sort of flipped it. The breakdown of this number would have been 169 and 11. And the square root of 169 is 13. Keep the square root of 11. Do you see what this person did? It's like they broke out the 11 and forgot about this. They flip-flopped the idea. Now, the reason I had you go through all of them, even though B was the answer, come back to this. The square root of 32 is 5.56 on. 4 square root of 2, the most simplified root, is the same answer. But the same answer came from this. And the reason I wouldn't pick this one, is the 8 could break down. So you could have more than 2 answers that give you the same decimal. But only one of them is the best answer. And that's called a distractor answer in a multiple choice test. So you're talking about your Keystone test, you're talking about SATs, or your old PSSAs. They might have 2 answers that give you the same decimal, and they're testing are you using your calculator skills or your understanding. This is not the best answer. Does that make sense? So if we would have had two that gave us the same decimal, we would have had to look more closely. Okay, with that in mind, go ahead and look at number 10. I made you multiple choice because it was such a big number. So use that multiple choice to your advantage. Let's do the square root of 2048. I think it's good to write that down. It's approximately 45.25. Now that goes on, that's my approximation. So you're literally going to go through and type in 2 square root 512. Oh, look at that. I think it's the first one. However, I don't know if it is because did I get the biggest perfect square? All right, let's do 4 square root of 128. Oh no. So do you see that we would be wrong if we would pick one of these two until we try everything? Ooh, guys. Same thing here. How about the last one? So this is the only one we could throw out. Do we agree? So which answer is the best? C is the best. Why is C the best? All that and on your phone. It is to simplify the furthest. 128 breaks down. I mean, there's at least a 4 in 128. 128 divided by 4. I think you could take 128 and divide it by 16. Heck, could you take 128 and divide it by 64? I sure could. So this would be 64 and 2. So there's a perfect square in here. I guarantee 512 divides by 4 because 500 divides by 4 and so is 12. And look, we get 128. So we could have divided this by at least 64 or higher. So these have perfect squares in them. That's the other thing to look for. This 2 cannot be broken down anymore. Okay, while we're in that mode, let's jump down to number 12. Same idea. Get all your decimals. Square root of 5202. So you can't just believe the first thing you get. You have to find the best answer. C, right? That one was C, yes. 32 square root of 2. 72.12, and this goes on. Okay, so I'm going to type these in. 3 square root of 578. Oh, I got the same answer. Should I pick it? See, that's the thing with multiple choice tests. A lot of people grab that first answer that they agree with. You really should try all the answers. Oh, and you know what else they like to do is pick all that apply. They don't really do that on your standardized test. But the other thing that can be is pick the one that's not true. You ever see that? And then the first one's true, so you're like done and you just missed it. So this one also works. And guys, I'm going to go on a limb and say this is my answer. Why can I be pretty sure that's my answer? Yeah, there's nothing else I can do with this. This is the same decimal, but 578 definitely breaks down with the perfect square. Okay. This one can't go any further. I'm still going to try this next one. Oh, no, that one's not even the same decimal. So we're happy to knock that one out. And 2 square root of 51. So you see that one's backwards? This is for the person who sort of flip-flops the idea and puts the root in the wrong spot. Okay, so that is my best perfect square, most simple. All right, last one you're breaking down on your own. It is the square root of 350. So get your perfect square list. What would always go into hundreds, 50s, 25s?
75.
Well, 75 might, but that's not my perfect square list.
5.
25, which would be the square root, would be 5. Now, how many times does 25 go into there? Because we could still go bigger. Go big or go home, right? Okay, it goes in 14 times. Now, 14 breaks down. 7 and 2, 14 and 1. But does 14 have any perfect square factors? No, look. 4, 9, they don't go into it.
9 gets 5, and then the bar looking thing.
The radical?
And 14.
That's called the radical.
And I got that in.
There you go, 5 squared of 14. So you did find us the biggest perfect square. Fabulous.